Hi guys, for today you need a piece of paper, either regular lined paper or graph paper is fine. I'm going to fold it like this. You watching? I'm going to fold vertically first, this direction. And then while it's folded like this, I'm going to turn it sideways so you can see the whole thing. And I am going to fold in thirds this direction. We all know thirds is a little tricky. So usually before I crease that one, I'll kind of fold this one inside and just kind of eyeball it here. Doesn't have to be perfect. This is the point where students always tell me, wait, can't I just fold it in half and then go to the middle? You're going to get 4 that way. I mean, you'll see it'll happen. So don't try to do that. Don't fold it in half. It won't work. You can't get thirds that way. So what I had to do was overlap them to get thirds. And the reason I did that is because I want 12 boxes. These first two boxes are going to be examples. So I'm going to write example 1 and example 2. Okay, we are practicing surface area, but these first 2 examples, instead of pictures just to practice, there's going to be some words here. All right, first problem. Go ahead and pause and write this down so that future you knows what work you were doing and why. So example 1 says a soup can has a height of 4.25 inches and a diameter of 3.25 inches. I looked that up. That's real information. Standard Campbell's soup can. Can you picture it? If you're picturing it, can you also tell me what kind of figure it is? A cylinder, right? A soup can is a cylinder. Here is what I want to know. I want you to find the surface area of the soup can. So I'm going to write SA equals, because I know this is a cylinder. I know the formula is 2 pi r squared plus 2 pi r h. That's what we learned yesterday. That means in order to find the surface area of the soup can, all I need is R and H. Can you find those things from that story? Well, R and H. A height of 4.25. That's going to be the height of the cylinder. The height of the can is the distance between the circles. Ooh, this tells me diameter of 3.25. That means I need to go 3.25 divided by 2, and that means the radius is 1.625. I'll just use all of that. Be nice and exact. It's terminating. It's fine. Which means now I'm ready to come back to my formula. I'm going to go surface area equals 2 pi r squared plus 2 pi r h. Lots of decimals, but really the fact is it doesn't matter. This is why we have calculators. We don't want to do all this by hand. We just need to know now how to do it and what the calculator is doing for us. And then we can trust the calculator to do it. So here I go. 2 pi r squared plus 2 pi r h. And that means the surface area of a soup can is 59.98 square inches, which what does that tell you? Well, it tells you, some people will say it tells you how big the label is. Actually, no, because the label's not the circles. The label's just the big rectangle. It tells you how much aluminum it would take to make the can. The entire surface area is the material it takes to make the can. Okay. Example 2. Here it is. Pause and write it down. The dimensions of a tissue box are 4.5 inches by 6 inches by 10.5 inches. What am I describing if I'm giving you 3 dimensions and I'm talking about a tissue box? Oh, a rectangular prism. Okay, so the surface area of a rectangular prism is going to be 2b with a capital B plus ph with a capital P. That means those are things that we need to calculate. All right, so I'm going to do capital B, capital P, and H. Now with a rectangular prism, there is definitely more than one way you can do this. And normally when we have a picture, we choose one rectangle and we shade it in and we say, okay, this one's my base figure. When we don't have a picture, we're still choosing the same way. And when you do that and you pick a rectangle and shade it in, you're just using 2 of the 3 measurements given, right? So let's just do that here. Let's just pick one. Let's say the base figure we're going to choose is 4.5 by 6. That's these two, 4.5 by 6. So those two are going to be my base rectangle. Even though I don't have the picture, I can still do that. So that's 4.5 times 6. That means the area of the base is 27. Whatever you choose to be your base figure to get capital B, remember, use the exact same figure to get capital P, right? So capital P is going to be 4.5 plus 4.5 plus 6 plus 6. One is the area of that rectangle, and one is the perimeter of that rectangle. So when I add that all up, I get 21. The area of that base is 27. The perimeter of that base is 21. Now, which one would be the height? Well, the other one. If this one is the shape of my base, the rectangle I'm choosing to be my base, then the distance between them is going to be the third leftover measurement, the one I haven't used yet. I don't even need a picture. That's how it's going to work. So now I am ready to plug all that information in. I'm going to go SA, surface area equals 2B plus PH. These are the two formulas you need to know for surface area, and you need to understand when to use them. Triangular prisms and rectangular prisms, surface area is 2B plus PH. Cylinders, 2 pi r squared plus 2 pi r h. Once you plug it in, 2 times 27 plus 21 times 10.5. Again, once I set it all up in the formula, look, I just typed it all into my calculator. 274.5. The surface area of that tissue box is 274.5 inches squared, and that tells you how much cardboard it would take to make that tissue box. All right, for the rest of these boxes, so those are examples 1 and 2. You have 10 more boxes because you're going to do 10 more surface area problems. If it is a cylinder, the rest of these are going to give you a picture. They are going to give you a picture. So if it's surface area, you're going to use this formula. Surface area is 2 pi r squared plus 2 pi r h. If that's for a cylinder, the one with the circles. Everything else, rectangular prisms and triangular prisms, will use this one. So now you're just going to number the rest of this 1 through 10, number these boxes 1 through 10. So you got 3, 4, and then flip your paper over and do 5, 6, 7, 8, 9, 10. And then go to the Nearpod and give these a try. By the end of today, you want to feel really good about surface area.